Welcome back to the South Carolina Water Resources Conference. I'm Donna London, and joining me today is Mr. Eric Strom. He is the Director of USGS South Carolina. Eric, thanks for joining us today.
It's a pleasure to be here.
This has been 3 years running, or 3 conferences running, I believe, so it's so great to see you again and to be brought up to date about what's going on with USGS. That's the U.S. Geological Survey. Before we get to that, I do want to ask you, I've heard a number of times over the last couple of days here at the South Carolina Water Resources Conference about the maps that a number of people are using, and they're referring to them as new Geological Survey maps.
Okay, yes, you're probably talking about a new product that we have out that is available to the public. You can download these maps. They're in a format that allows you to put different layers that you wish to see on the surface. Old aerial photos, the old topo maps, the new topo maps. They're a very popular product. The topographic maps have always been our staple.
Well, you say that they're available to the public, but can the public really use them? I mean, someone like myself.
Well, if you've ever gone hiking or to a national park and brought a map with you, then yes, you can.
Okay.
These maps are in a format that would allow you to have them printed off at a print shop in a large format if you didn't happen to have a printer that big.
Okay.
Or of course you can carry them as a digital version. Even loaded onto a smartphone. So
that's pretty amazing.
I think that they would be very usable to anyone.
Very customer friendly, it sounds like.
Very customer friendly, we hope.
Well, tell me about some of the other things that are going on since the time that we met last time.
Well, we've had some really good technological innovations. That's the nice thing about the passage of a few years. It's amazing how fast technology marches on. And we've acquired a new tool. It's like it's an autonomous underwater vehicle, AUV we call it for short. It's like a torpedo. It's about 5 feet long, shaped just like a torpedo, so we have to be careful with it when we're in public.
Oh, I bet.
And we can program this torpedo to do missions, water quality missions. It has in its nose sondes, sensors. Anything you can put into a regular sonde, we call it, you can put into this device. So we can measure temperature, pH, we can measure blue-green algae, specific conductance, the basic things that you would measure out in the field. But the big difference is when you go out and make a measurement, you're measuring one point in a reservoir, or maybe you're measuring just a transect across a river. This is programmable to measure an entire small reservoir in one day in 3 dimensions. So it can travel along the surface, it can undulate up and down to get a 3D picture, and it can hug the ground. We program a mission, that's what we call it, a mission, into this device. It swims the mission and then comes back at the end of the day, and we have a complete three-dimensional picture of water quality. And that's something that's very new.
That is amazing. But how would that be used, the information that you gather?
Well, I'll give you an example. We're using it right now to work with Charleston Water System down in the Bushy Park Reservoir, which is the water system that supplies water for 400,000 people in Charleston. And they are concerned that some of the dynamics of that system are going to change in the future with some decreases actually in pumping. And they wonder how that might affect the water quality. And so we have mapped and continue to map bi-monthly the water quality in that reservoir in 3 dimensions so that we can understand the system as it is now and understand the system as it may change in the future. We've also used a device, it also has a side scan sonar, which isn't water quality related, but it allows it to map the bottom of a reservoir. And we've used that, for example, with Greenville Water System to map Table Rock Reservoir, their water supply. And that allows them to know the volume of water in that reservoir at any given stage. So
amazing, amazing. In terms of the applicability of that, is it something that you would also use in the coastal areas, perhaps to look at sea level rise, or what you're going to be missing once that time comes?
What you could use it for in the coastal area is characterizing, say, the saltwater wedge as it's coming up a river. You know, you can map something like that in 3 dimensions. You know, in an estuarine environment, flows are sometimes out to sea and from the sea, depending on the tidal cycle. So with specific conductance, it can kind of map these changes in water quality in those environments.
Amazing. I guess all of this brings to mind some of the discussions that were taking place over the course of the past 2 days, particularly related to the importance of not only technology advancement, but also in terms of the academic community's involvement in conferences such as this. In your mind, what is the importance of an academic conference and academic gathering that includes all of these other stakeholders, such as yourself, and the community, the environmental community, and the citizens at large in this one place?
Well, that's the beauty of this conference. There's no other conference I'm aware of in this state that brings together stakeholders that have an interest in hydrology and water supply and water planning. And the USGS here in South Carolina partners with about 40 different cooperators, state agencies, utilities, etc. And all of those people are here. So it is a time to get out and really find out what their needs are, hear from them in the talks and the panel discussions, and have those sidebar conversations. We've had many such conversations that will lead to us partnering with them to try to help them with the issues they've identified.
And of course, in a number of the discussions that I had over the course of the conference, related back to those first maps I was discussing, where people were saying that they had some of their base data already from the maps that USGS was providing.
Yes, they are used commonly as a base map for the start of any project. And again, they're also available in a GIS format, and that's what most scientists are actually using these days for putting their data on what we call a georectified surface.
So now what's next for you and USGS in terms of the water planning process, but other items that you have going on?
Okay, in terms of the water planning process, I think we heard at this conference a lot about the state water plan and the future of the state water plan. Ken Rentiers gave some excellent talks on where they are at with Ken Rentiers of DNR gave some excellent talks on where they're at with that and their plans for the future. And they're concentrating on the surface water aspect of it right now. But you may recall that the second phase is groundwater modeling in the coastal plain. And USGS developed a groundwater model some years back in the coastal plain that we intend to use as a base and recalibrate, improve that model to meet the needs of the new state water plan. We'd like to work with DNR on that and have let them know we're ready to be a partner as we move forward.
Wonderful. When we come back in 2 years, what are you hoping that will have changed over the 2 years in terms of water resources in South Carolina?
Well, that's a really good question. We see changes in technology that happen very quickly, but changes in policy, say in implementation and all, they occur at a bit slower pace. And what I would like to see is more confidence that we have the data that we need to continue to move forward. I think, I don't recall the gentleman's name who said it, that we continue moving forward now because we have a lot of data, but those gaps be resolved, or at least we make good progress on them over the next 2 years.
Well, I hope that you're correct and that we're going to see that as well. And I want to thank you for joining us today and look forward to having you back in 2 years and celebrating that fact, hopefully.
I hope you're correct. One last thing I'd say in terms of technological advances, I'd be remiss if I didn't mention our networks, our monitoring networks.
Yes.
And we obviously monitor about 170 stream flow sites in real time, about 50 water quality sites in real time, and about 20 groundwater sites in real time. But one thing we've done is we've allowed the public to access these data really simply. We have something called waternow@usgs.gov. It's an email address, waternow@usgs.gov. If you text that on your phone and then you put in the station, any of our gauging stations, water quality station numbers, any of that, just text it and that station will text you back with the current conditions. So
that's pretty cool.
We're also, if you don't want to, if you'd rather be alerted when a certain threshold's met, let's say you're a kayaker, and you know that when a certain stage is met, you want to get out there and get some white water underneath you. Well, we have something called Water Alert, and if you just go to www.usgs.gov/water alert, you can choose your favorite gauge, and you can say, hey, when you're at 5 feet, text me or email me, alert me. I want to get out there with my kayak. So I think we really like to innovate in ways of getting data that people really want out to them as innovatively as we can and as quickly as we can.
All sorts of applications for that, which is phenomenal, that I'm sure I haven't thought of yet, but sounds like you folks have, and that's really exciting news to hear. Another reason to play with our telephones.
Exactly, exactly.
Well, it's been a pleasure talking with you, Eric Strom from USGS, and I want to be sure that you stay in touch with us and that we have you on again in 2 years at a minimum, if not before.
Okay, I hope to see you then. Then thank you, the pleasure's been mine.
I've been speaking with Mr. Eric Strom. He is the director of USGS South Carolina. For the Jim Self Center on the Future, I'm Donna London.